The idea I'm going to discuss this evening is the idea that our minds are much more extensive than our brains. They stretch out far beyond the surface of our bodies. The standard view within the academic world is that minds are brains. The mind is nothing but the activity of the brain, and all your mental activities inside your head. I'm going to suggest that our minds stretch out beyond our brains through fields, and these fields are a variety of what I call morphic fields, organizing fields that are involved in all forms of life. I'll talk more about these later, but first I just want to give a sense of the way in which fields in general stretch out beyond things. And we all know about fields. Magnets, for example, have fields, and the field of a magnet's inside the magnet and stretches out beyond it as well, beyond its surface. The Earth, of course, has a gravitational field which stretches out far beyond the surface of the Earth. It keeps the Moon in orbit round the Earth, and the Sun's field keeps the Earth in orbit round the Sun. And then mobile phones have fields. It's precisely because they have these invisible fields around them that they can send messages. And the messages are going out through the electromagnetic field, and these fields go out far beyond the surface of the mobile phone. Now, I think our minds are like that. They're based on fields which are rooted in our brains, usually, but which stretch out far beyond them. And as soon as you have the idea of the mind as a system of fields stretching out beyond the brain, a lot of phenomena that otherwise seem mysterious begin to make perfectly good sense. In fact, from the mind in the brain theory, the standard view, anything that doesn't fit, that suggests the mind has an influence at a distance, has to be rejected. And that's why there's such a strong taboo within institutional science about subjects like telepathy. Many scientists say they're impossible, they can't exist, and therefore all the evidence for them must be flawed. This is really a dogmatic position that follows from a particular theory of the nature of the mind. When we go beyond that theory, it's possible to look rationally and scientifically at a whole range of phenomena that until recently have been very much neglected within science. I'm going to start by talking about vision. And I'm not now talking about visionary experiences of the William Blake type. I'm talking about ordinary vision like you seeing me standing here now. Strangely enough, something as fundamental as our own vision is not understood scientifically. We really don't know how it works. What we do know is, and what everyone agrees about, is that light travels, as you see me, from me through the electromagnetic field into your eyes, inverted images on your retinas, changes in the cone cells, impulses up the optic nerve, and then changes in various regions of the brain. These have all been studied in detail by electrophysiology, brain scanning, and so forth. But it's very good as far as it goes. It just doesn't go very far, this particular theory, because once you've got all these changes in the brain, then does that amount to vision? No, it doesn't. It amounts to changes in the brain. The fact that you see me standing here is completely unexplained by that theory. First of all, consciousness itself is the deepest of all problems for science. Some philosophers call it the hard problem, because it's something that doesn't in any obvious way flow from physics, chemistry, and biology as we know them. You can find correlations within the brain to conscious states, but that doesn't mean to say the conscious states are those changes in the brain. So consciousness is the first problem, why you see anything at all, why you're aware of anything at all. The second problem is the fact that the changes are going on inside your brain. The standard view would say all your vision occurs inside your head as a result of changes in the brain, and yet I imagine you're experiencing your image of me not inside your head, but located where I'm standing. The theory I'm putting forward is so simple that it's hard to understand. And that is that your image of me is located right here. It's an image in your mind, constructed and interpreted by your mind, but it's not inside your brain. It's outside your brain. It's where I'm standing. And your image of this room is where it seems to be. And if you look outside, you can't see the stars because it's raining. But if you could see the stars, then your image of the star would be where it seems to be. what I'm suggesting is that vision's a two-way process. Light comes in, changes happen in the brain, and the images are projected out to the place where the objects actually are. Of course, they can sometimes be projected to places where things are not, in which case you have an illusion or a hallucination. But luckily, most of the time, that doesn't happen. If it did, most of us wouldn't have got here this evening, because if you didn't see cars and people where they actually are, you'd be bumping into things all the time. You wouldn't survive for very long. So natural selection has ensured that this projection process is, in fact, normally extremely accurate and corresponds very closely to where things are located. So, in a sense, what I'm saying is our minds reach out to touch what we're looking at. The images are out there as they seem to be, not inside the head. The conventional position leads to very peculiar paradoxes, one of which has recently been pointed out by a philosopher, which is that when you look at the sky, the conventional view is that all your images are inside your brain, like a kind of virtual reality display. So when you look at the sky, your image of the sky is inside your brain, like all other images, which means that your skull must be beyond the sky. And when you look at the sky on a nice sunny day, and there's this big blue sky or the stars at night, it's an amazing thought that the official theory says your skull's beyond the sky. Most people think their skull's where it seems to be, and that's what I'm suggesting. I'm suggesting your image of the sky is actually where it seems to be, outside your skull. But it's amazing that in this day and age, in the 21st century, this issue is completely open and unresolved. Many philosophers have supported the idea that vision's a two-way process. This is not an original theory of mine. It's a very old theory. Plato supported it. Euclid supported it. Most medieval philosophers thought in terms of a two-way vision process. More recent philosophers like Henri Bergson, the French philosopher, and Bertrand Russell have thought it was a two-way process. And the studies on developmental psychology by Jean Piaget, the developmental psychologist, have shown that most children believe vision's a two-way process. Until the age of about 10, as Piaget says, the average child believes vision involves this two-way process, an outward projection of images. But after the age of 10 or 11, the average child learns the correct view, which is that thoughts and images are invisible things located inside the head. So probably all of us believed in this two-way theory when we were young, although we probably wouldn't have explicitly said it. We might have done if we'd been asked the right questions. So there's nothing very new about this theory. But the question is it true? How can we test it? I'm talking not about philosophy, but about science. So if this is a scientific idea, then what can you actually do to test it? Well, it turns out that you can test it. When you look at something, your mind reaches out to touch what you're looking at, then you can affect what you're looking at just by looking at it. Now, is that true? Can you affect things just by looking at them? Now, if you think in terms of another person, the answer becomes clearer. Imagine I look at you from behind. You don't know I'm there. And I can even look at you through a window so you can't have any sound coming from me or smells or hear no normal sensory information. And I stare at the back of your neck. Would you be able to tell that you were being stared at? Now, as soon as you ask that question, you realize the sense of being stared at is a common experience. Most people, the great majority, in fact, have had the experience of turning around to find someone staring at them, or looking at someone from behind and noticing them get restless and then turn around. Surveys have shown there's a slight sex difference. More women than men have experienced being stared at, and more men than women have experienced staring at others and making them turn around. But the majority of both sexes have experienced it both ways round. So this is a terribly common experience. So what does science have to tell us about this well-known phenomenon? Well, the answer is almost nothing. Until between about 1880 and 1985, there were virtually no investigations. There was a total of 4 published papers in the scientific literature, 3 of them showing positive results in favor of the sense of being stared at. there's been a complete taboo, really, about thinking about it. Everybody knows about it, even children in primary schools. Yet it's something you cannot discuss because it's just too awkward or embarrassing. It goes so far against the standard mind and the brain theory that the phenomenon's been treated as taboo. It's astonishing the way it's been suppressed and